Let's explore this expression. Open parentheses 2m, close parentheses, raised to the power of 3. Now again, go back to the definition of exponents. In this case, 3 is our exponent, and because the value's inside the parentheses, that will be our base. So we can rewrite this as 2m times 2m times 2m. Now again, I want to make sure I really understand this. 2 is touching m means that's actually multiplication. So I can interpret this as 2 times m times 2 times m times 2 times m. And again, in this case, notice we have two different categories. We have numbers, so I can group up the 2's and make it 2 times 2 times 2. And the other group is m times m times m. And I'm able to do this using the commutative property of multiplication. Now, 2 times 2 times 2, because the same values being multiplied, repeated multiplication, we can use exponents. That is the same thing as 2 raised to the power of 3. Now, the other set of m times m times m can also be written using exponents, and in that case would be m to the power of 3. Now for here, what do you notice? Well, notice 2 to the third is a value we can calculate. It's reasonable. So in this case, we do need to take it a step further. In that case, we could simplify and find that value, which arrives to the value of 8m to the third. Now, surely there needs to be a quicker way to go from the original problem to the simplified answer. Can you find the pattern? Well, that brings us to the power of a product rule for exponents. It states, if n is a positive integer and a and b are real numbers, then open parentheses, a times b, close parentheses, raised to the power of n equals a to the power of n, b to the power of n. In other words, we distribute the exponent to each factor inside. Simplify each expression. For example A, we have open parentheses, x, y, close parentheses, raised to the 7th power. In this case, we recognize the exponent is 7 and the base is x and y. Since we have two factors inside the parentheses, we must distribute the outer exponent to each factor. When we do that, that will become x to the power of 7, and then we distribute again, which makes it y to the power of 7. Then, if possible, we simplify. In this case, x to the 7th, y to the 7th cannot be simplified, and that is our answer. For B, we have the problem, open parentheses, 3y, close parentheses, raised to the power of 4. In this case, we cannot simplify anything inside the parentheses, so now we're ready to deal with the exponent. The exponent on the outside must distribute to each factor on the inside. The first factor would be a 3, so we write that as 3 to the power of 4. The next factor is y, so it'll distribute and become y to the power of 4. Once we have distributed the exponent, we want, if possible, to evaluate anything. 3 to the 4th is something we can calculate. 3 to the 4th really means 3 times 3 times 3 times 3, which is a value of 81, and y to the 4th cannot be evaluated, which means it stays the same. For example C, we have open parentheses, negative 2 p to the 4th q squared r, close parentheses, raised to the 3rd power. In this case, we approach the problem the same by distributing the outer exponent. The question is how many factors do you see inside the parentheses? Hopefully you noticed we have 4 separate categories. The first one is the number, so negative 2 raised to the power of 3. The next factor is p, so we write that as p to the fourth raised to the third power. Next we have q, which is q squared raised to the third power. And then finally we have r raised to the third power. So we have 4 different factors and we need to simplify them individually. The first value is negative 2 raised to the third power, which really means negative 2 times negative 2 times negative 2, which gives us negative 8. Next, we see p to the fourth raised to the third power. Notice your exponents. They are touching, they are side by side, which means we can multiply them. So we can simplify that and make that p to the power of 12. Next, for q, we have q squared raised to the third power. Again, notice your exponents are side by side and touching, which means again we can multiply, making that q to the power of 6. And then finally, we just are left with r to the third power. So in the end, our simplified result is negative 8 p to the 12th, q to the 6th, r to the 3rd.